Last week we discussed a chemical change. We cooked sugar down into caramel, and since it can't be reversed back into sugar, it's a chemical change. Now, a physical change can be reversed, and we will see how in today's experiment. Today we will just be working with water and salt, so there's no need for any safety equipment for this experiment. But just as a fun fact, the table salt that we use to flavor our food is sodium chloride. But there are many different types of salt out there. Salt, simply put, any chemical formed by an acid losing its hydrogen and it being replaced by a metal. Now, not your typical metal like when you think of jewelry or coins or most things that you hear called metal. Sodium, calcium, magnesium, potassium, these are all metals. Do you remember our acid experiment? When we mixed the acid and base together, we made water and salt, which was our neutral solution. Now, this is not the salt that we use, so please do not attempt to eat it. But nonetheless, a hydrogen was lost and replaced by a metal to create salt. And now that I've confused you, let's get back to today's experiment. So we will start by making salt water and putting 2 teaspoons of salt in a 1/4 cup water. And you just swish it around, try to get it to dissolve a little bit. And now I'm going to put it in front of a window that I know is going to get enough light. This will help it to warm up a little bit more and speed up the process just enough. So I said that this would take a few days, but here we are on day 6, and as you can see, we still have a little bit to go. So this will probably be more like a couple weeks. But if you look inside, you can see the salt crystals already undissolving from the water. Okay, so I said this would take a few days, but it's more like 2 weeks. The good news is that you can completely forget about it and then check back later. Now, it is better, if you remember, to mark the water levels, and that way you can actually observe what's going on here. And what we observe is the water very slowly evaporating from the cup, and what you're left with is the salt. Now, water is liquid at room temperature, but the temperature in the room will very slowly heat up the water enough to evaporate. And the salt, because it is solid at room temperature, needs a lot more heat because it first needs heat to transfer into a liquid, and then it needs even more heat to transfer into a gas. So what happens is the water evaporates while the salt gets left behind. Now these watermarks are just so that you can observe the water evaporating because you can't see the water vapor. Just like God, right? You can't see him, but he's there. Now, you can speed up this process by adding heat, but if there's too much heat, then you may also melt and evaporate the salt. So, I just kept it simple. When we dissolved the salt in water, we made salt water. It's a completely different substance that has different properties than the salt or the water by themselves. But this reaction can be reversed. As we saw, we separated the salt and the water. Last week, we changed sugar into caramel, and the caramel could not be reversed back into its sugar. That was a chemical change. Now, this is a physical change because we did make a completely different substance, but we were able to reverse it. Now, if you wanted both the salt and the water, you could use a cooling apparatus. You would set it above the cup, and when the water evaporated, it would hit the cold apparatus and cool back into a liquid, and it would catch in a separate cup. Now, that's not something you have laying around the house. That's something you would see in a laboratory. So again, we kept it simple. But it is possible to have the salt and the water that you started with, and this is what makes it a physical change.